Hello! Today we will be using Concord to build a basic model which will generate a phrase of symbolic music deterministically, and we can then play this phrase back using a meta sound. To do this, first up you'll want to pull up a fresh copy of the third person template in a new project, and then just open the content browser, right click and browse to Concord, and then Concord model to create your new model asset. And I'll just call it a basic model. You can then open this up to reveal the Concord asset editor, which is a graph editor, just like Blueprint or Metasound. Here we don't create logic or DSP graphs, but rather we create vector graphs, which are graphical probabilistic models, which let us model a distribution over random variables. In this tutorial we will not be using random variables, but we will use the graph editor to create a Concord model that always has the same output, and just to show some of the functionality and how to get started, before going into the more probabilistic side of things. So the first thing you can do is you can create an arrange node. Arrange nodes generate a sequence of numbers from a start to a last using a certain step size. If we want to see an output of a node, we can simply drag off the pin and then create an output node. We can simply leave this as new output and then press the spacebar or click on sample variation to run the model and generate an output. And here we can see that our arrange node has counted from 0 to 9, as we expect. We want to output the MIDI notes of a musical phrase using this model. In MIDI, the middle C is at 60. So let's start at 60 and then count up to 67 with a step of 1. Now that we have this output, we can preview how it would sound with a sound generator using the preview settings over here in the detail tab. So open up preview if it isn't already, and also the latest pattern sampled from editor, which is this one right here. And we can now set a preview sound. Concord comes with two preview sounds tagged as tutorial_keys or piano. I will be choosing the piano preview sound right here. But before we can play this back, we still need to rename this output so that the sound knows what to play. And you will do this by entering a path right here, which has the form instrument/type. So I have typed piano/notes, since the instrument is called piano, and the what I will be sending to the instrument in this output is notes. What kind of instruments are available depends on your sound, and we will be going into detail on that in further tutorials. Now I can press play to audition the sound. The tutorial piano sound has a pattern length of 32, so we can send 32 individual note or pitch events until the pattern either repeats or is done. So far we have only sent 8. Let's make this a bit longer by adding a bit more complexity to this model. So what we'll do now is just grab this arrow off. You can do this by holding Control and then dragging off this pin, and insert a repeat note between the arrange and the piano notes output. If I mark all of these notes and hit Q, it will straighten the connections, which is a nice feature. Your keybind might vary, so just look for the straighten connections keybind. We can now change how often the input of the repeat node is repeated by selecting the repeat node and then editing the repeat shape in the details tab. For now, I will just have one dimension of repetitions, and I will repeat this 4 times. And so on. Now let's make the melody a bit more interesting by adding a reverse node to the graph, dragging off the arrange output pin, and then adding a concat node to the graph by simply right-clicking anywhere in the space, then dragging off the arrange node output pin and connecting it to the first input pin on the concat, and then doing the same for the reverse output pin. We will then once again repeat this so we get up to 32 steps. But now, since we have 16 or 2 times 8 values coming through this concat node, we can only repeat this twice. Last but not least, we will use yet another node to actually play through a musical scale instead of just playing consecutive MIDI note numbers. This node is called toNote, and it has multiple input pins. One is the root, then we have one for degrees, and then another one for the scale that we actually want to use. So we can leave the root at 60, which is middle C. Then we will treat our values that the range node produces as degrees in a scale. So we will not count from 60 to 67, but rather we will count from 1 to 8 to fill out an octave. And then we can connect this up to the degree input. Lastly, for the scale, we can just drag off this input pin to create a parameter node. And it's called parameter int. You want an integer parameter here. And we can just name the scale. And then in the details tab here under parameter default crate, we can select a crate, which is basically a container of values that Concord uses to read the values from. So just check this box saying get default values from crate, and then under the default crate object selector, just type scale in the filter and you'll see this Concord scales crate, which comes with the plugin, which you can select. Inside this crate, if you open up the crate data int blocks tabs, you'll see a number of scales that you can use. Those are labeled with the corresponding modes, and Ionian is the basic major scale. So we'll just type Ionian here in this default values crate block name. And now if we just grab an output node here, we can see we get these values, which are semitone differences. So 0, 2, 4, 5, 7, 9, and 11 corresponds to the basic major scale. Now we can use this node output for our piano notes, run the model by hitting spacebar or clicking the sample variation button, and now we can play back the scale. Alright, this is our basic deterministic Concord model that just generates some musical output, and we can play it back using a tutorial piano meta sound. In the next tutorial, we will be looking at how we can use random variables to create models that do not deterministically produce the same output, but rather create a system of possible outputs, and then we have truly generative music. Thank you and goodbye.